Hello guys, my name is Diego Pacheco and this will be a Java video. So today I'm gonna talk with you about mutation testing, and we're gonna be a very practical hands-on video using Pitest in Java. So mutation testing is not new, was created on the 70s, and it's really interesting idea because it harden our tests. And basically, if you think about it, mutation testing is basically testing our tests and basically introducing bugs in your tests and therefore hardening our tests in our code. So let's get started. So I will share my idea here, and there we go. So opening my idea. Here I already have Pitest configured with Maven. So if we go on the pong.xml, you're gonna see there is a Pitest Maven 152, and I'm using this dependency here so I can make Pitest work with JUnit 5. And here I need to tell what are my target classes and my test classes. So they're all in the same package. And here I have JUnit 5 and some other JUnit dependencies. Okay, so I have a very simple calculator, right, that can do sum, multiplication, division, and subtraction. As you can see, I just received two doubles and I do the basic math operations, right? And I have a test here, which right now I don't have any test implementations, and I also have a suite to kind of run all my tests. So let's get started, right? So in idea, if we try to run, we actually cannot run this because we don't have tests, right? So let's add one test here, right? So let's start with sun. Okay, so sun test. Then we're gonna create a calculation service. I'm gonna call it CS, and then I'm gonna do CS dot sun, and I'm gonna plus one, right? And I'm gonna add test. So it needs to be double, so I'm gonna pass a double here. Yeah, so let me run. Okay, my test is passing. Then in idea I can run with coverage, right? And then if I open my implementation class, we can see I have 25% coverage because I just tested sun. So let's test mul, divide, and sub. But let's do this mul for now, right? So let's go here, and then I'm gonna copy this, and then I'm gonna do mul, right? Mul test, and I'm gonna call mul. So 1 multiplied by 1, right? And then I can run. It's passing. If I run the coverage report, you're gonna see it's 50% now. And I look here, 2 is green. Okay, there's 2 missing, right? So now let's run Pitest. I create this run.sh script where basically I'm calling this go Pitest Maven plugin mutation coverage, right? So I don't need to type this all the time. Okay, so let me open my console and we're gonna run this guy, right? So we're gonna do this. Oops. Java Pox, PLC, Pitest, Maven, this one. Okay, so I'm gonna do run, right? And Pitest is running. And now if I take a look on my target folder from Maven, there's a Pitest reports. And if I open that, I'm gonna see I have a report. My line coverage, it says, is 60%. However, my mutation coverage is 0, right? And let's take a look there. And you might be wondering, why 0, right? If you look my idea, it says I have at least 50% coverage, right? And we can look our tests here, and actually we see 2 tests. So why 0, right? Well, we was able to fool line coverage, because line coverage is a flawed metric, right? It can be gamed, and that's exactly what we did. However, it's much harder to trick mutation testing than coverage testing, right? And if you see here, we have some mutants that survived, that all the bugs that was introduced in our code, and we can see we have problems in all our methods, right? But if we look the code again, sun and mu should be okay, right? But if we look here, sun and mu are not okay. And we look here, right, it says that the bug introduced that just returned 0 here, and it was all good. And the reason that happens, right, is because our test has flaws. And the flaw here is we are not doing assertions, so you're not testing anything, right? But line coverage says that we are testing, right? So that's kind of the thing, right? So we can fix this with assert equals, and then I want to say that 2 it should be equals to this, right? And we can do the same for multiplication here. So this should be 1, right? Now if I run it, you're gonna see that our tests are passing. If I run the coverage, you're gonna see my coverage is exactly the same, still 60%, 50% of methods, 6%, right? However, if we go here and we rerun the mutation, right? Now we need to open another file. There you go. Okay, now, right, if we take a look here, things improved, right? My sun is fixed now, right? But if you take a look here, I still have problems with mu, I still have problems with divide, I still have problems with sub, right? So let's fix that, right? So if I go back here, and we look the code, all right? Let's add the other tests first, right? So let's do sub, and then we're gonna call sub. So one minus 1 should be 0D. Here should be 1D. And finally, division. So div. So we do div test, right? So let's put 10 for instance here, and then if we do 100 per ten, should be 10, right? So let's run. So as you can see here, my test is failing, right? Because I'm calling sub, right? And I did that by design. I should be calling div, right? And let's see what happens if I try to run the mutations right now. And that's a cool feature about the mutation testing. I cannot run mutations right now because my tests are failing. And in order to run mutations, your tests need to be passing. So that's cool, right? You can fail the build because we have a build failure, right? If the tests are passing, your build gonna be failing, right? That's really good reinforcement, right? Really cool. Okay, so now let's do div here. It's actually divide, right? And then we can run this guy, and then they pass. If they pass, we can go here and we can try to run the mutations again. And now let's look our report. So let me delete this and I run this one. Okay, much better. So now we can see that we fixed sun, we fixed divide. We still have some problems with sub and mu, right? And if we look what they're saying here, for mu, it's saying that was replaced with 0, and for sub was saying was replaced for 0. So that was the bug introduced, right? So we have problems with mul and sub. All right. So if we go back here, we look our code. Mul looks correct. Sub looks correct, right? Looks all good. But if we look our code, right, our mul test here, right, we have this expectation, right, and also our subtest, we also have some expectation, right? So in sense of code, right, we really cover pretty much everything. So if I go here and I say, okay, let me run with coverage, right, you're gonna say, okay, coverage is 100% now, right? So 100% lines covered. If I go back to my service, you can see it's all green here, right? So we have all the lines covered. So 100% methods, 100% lines. However, we have 4 tests. We have a test for sum that we are passing 2 numbers, right? And we're doing the sum. We're testing for mul. We are doing the multiplication. We are looking for the value. We are testing for sub. We are calling that, checking for the value. We are doing the division, checking for that. And still, we are getting 4 tests here, right? But as we go to the mutations, right? So it's still not 100% happy, right? So let's run this guy again. All right, if I go here, you still see there's stuff missing, right? It's still complaining. And if you go here, it says, okay, I put 0 here and nobody cares, right? And I put 0 here and nobody care, all right? So we need to validate this, right? So there's a couple of things we could do. I don't know if you realize, right? But if I go back here to my implementation, you can see I'm receiving a double, right? So that could be null. So I can validate that. I can do objects require not null, and then I can validate that both args are not null, right? And that will definitely, because this is our object, all right? So this will improve my test game, all right? And I can go back here. I can run. My tests are passing. I also can go here, can test coverage. I can see they're passing, still 100%, right? One thing I could do is I could try go for null. So for instance, I can say test div test null, all right? And I can do assert throws where we can pass a lambda here and the exception. So we expect to have a null pointer exception dot class, and our code will be we are running calc dot cs dot div, and then we're gonna pass a and b. So we're gonna say that double a is null, double b is null, right? And we expect to get a null pointer here. So we run it. I have one more test. So now we can go back here. We can do the mutations again. So we go here. Oops, that's the wrong report. Oh. So this is the new file. I can open it, and I go here, right? And I can see that divide is fine now, right? But still complaining about mul and about sub, all right? So we need to do something. So let's go there. Let's try sub. So sub, and then I'm gonna call sub gonna run it. And then I go here, I can run again. And now I can here, and I can open the report. And as you can see, sub still complaining, right? And if you go there, you're gonna see replaced sub with 0, right? And survive it. So it's still complaining. And what that teaches, right? It teaches that if you have tests that don't add value, your mutation coverage won't change, right? So it only will improve if you really add value, right? And that's important property. So let's try to test with 0, right? That his bugs, he keeps saying that he's introducing a 0, right? So let's do that, all right? So but now we won't have an unpointed exception anymore, right? So I'm gonna have 0, and I'm gonna have 0. So actually what will happen now, we can do assert equals again, and actually will be 0, because 0 minus 0 will be 0, right? So then we're going to be call cs dot sub and a and b. That's our code here, right? So I can run it, and you can see it pass. Now I can go here, I can run my mutations again, and they finish it. I can go here, I can go there, and I can run. And if I go here, right, I just want to make sure, let me do close other tabs, right? Make sure we are getting the right guy. There we go. All right. As you can see, still nothing happens, right? It's still complaining, right? And we see that sub still doesn't like it, right? And we can see that here in the case of 0 is working for these arguments, right? But for sub is not working around. So is that test is still bullshit, right? So it no value whatsoever on the mutation point of view, right? So let's compare sun with sub, right? Let's see if there's any difference there really, all right? So if you go back here, so sun is actually arg1 plus arg2, and sub is really arg1 minus arg2. So no really difference in implementation standpoint. So if you go implementation, sun is actually 2, right? So 1 plus 1 is 2. And if I go check my my sub, right, I'm checking for 0. So let's check here, right? And let's put 3, for instance, right? So 3 minus 1 should be 2. So if he introduces a bug that's returning 0, I'm expecting 2 now. So something should be different now, right? So running my test always the same thing. So let me run here. Okay, and now let me go back here. Let me finish this. Let me run again. Oh, something happened, right? So you can see now we fixed sun. Because the mutator, right, the bug, we're gonna try to go here and say, okay, I'm gonna return 0. Do your test can take care of that, right? And unfortunately, the issue was like my corner case, my assertion was really on 0. So if he turns 0, I'm expecting 0. So it was really clever of the bug try to return 0, right? But now that I'm expecting 2, if you try to return 0, nothing will happen. And test things with 0 is really kind of a dangerous, right? So that was not a strong test. I could test with 0, but I should have other tests at least, right? Then we'll be stronger. Now we know what's going on with Mu, right? If you read here, is again saying that he's introducing 0. And if you look what we are doing for our Mu test, right? And let's look here, Mu, right? And let's let's fix this guy, right? And one thing we could do here, we could add another test, right? Let's say mu bigger, right? So we could say that we want to do 5 multiplied by 100, it will be 500, right? Then we can run it. There we go. And we can go here and let's run it. Let's see what will happen. Now let's go back here and get rid of this. And as you can see, we fix it. All right. So mutation test is really interesting because it will introduce bugs, all right, in your code, and will be much more harder than coverage testing. It will really catch much more scenarios. And Pitest has so many mutators, it can create a lots kinds of bugs, all right, for you. And it's really good. It really enforces interesting programming style, right? Like for instance, if I go here and let's say in my implementation I have private void persist on database side effect, all right? Nobody will be testing this, right? Let's say store data on DB. So let's say for some reason I'm calling this here on sub, all right? If I run my tests, sorry, I need to click on the test here. You're gonna see it's all work, no problem, right? However, if we go back to mutations again, now, and I go back here, sorry, I need to open here. What you're gonna realize, there's a problem, right? And the problem is this, right? He doesn't like that private method because he say, well, I just remove it, right? And it was good. So it means, let's say you are doing something here, not testing that, right? It's not testable because it's void, right? So that's really interesting because it's enforcing good standards. If we go back to IDEA and we just check our coverage friend here, it will say, no, it's all good. It's still 100% coverage, right? So that's really the problem with line coverage, right? So if I remove it here, and then I go back here, we can fix the mutation one more time. All right, and then I come here, and I run it. Yes, then I can go back here, this guy, and then it's 100 again, right? So that's mutation test, guys, is much more powerful than just relying on coverage testing, because line coverage has flaws. It cannot get branch variations, like if you have like a boolean, if you test it with true or false, if you have conditionals greater than, smaller than, if you have number ranges, you know, empty values, there's all sorts of bugs you could be introducing, and really mutation tests help you to improve your tests and make your tests more resilient, right? And if you combine with other tools like property-based testing, you can really do much more with less. So that's my video for today. I hope you guys like it. See you next time. Cheers.